In this video, we're going to take a look at Swift classes and inheritance relationships. We'll take a look at the concept of a superclass versus a subclass, how we can go about extending a subclass from a superclass, how we can write initializers in a subclass, how we can override methods, how we can go through and access and update property values in the superclass from a subclass, all of these good things. Now, if we conceptually think about how we build these types of relationships, when we start developing, we try to extract all of the properties that a particular group of things would have in common and place them in a superclass, because with that relationship, then we can go ahead and inherit those types of properties and or methods into subclasses. If we think about our situation with our bank account, regardless of whether we have a checking account or a savings account, we can make deposits, we can make withdrawals. If we put a lot of that logic within our superclass, we can take advantage of that base processing in our subclasses that we write. If we create an account ID in our superclass, we just get that automatically available within our subclass without having to recode it. So in a lot of cases, what we have with inheritance is we're trying to eliminate duplication of code for one thing. We're also trying to put things in more specific terms of I have an account and these are the properties and data related to that account. So we're trying to keep the data and the methods for a single thing all together and encapsulate it into one particular class. This is what we typically do when we're trying to build out applications. Then when we create our checking account, we only have to add those properties that are specific to a checking account that are over and above what we have in our superclass, and only those methods that are needed for that subclass that we have for the checking account. Or if we have a need to modify some of the behavior within a particular superclass that has been defined, like in the case of maybe the deposit or withdrawal, we can tweak that, but we can still rely on some of the base processing in that superclass so we don't have as much code to write. So let's go ahead and get started. I think this will be a little bit more self-explanatory as we go through some of these iterations and steps to take a look at how we can do this. And I think we're going to go back to our example that we had before. Not sure if I still have it open or not. Might have I have it open still. And we're going to extend that. And before all of our testing statements down below, one of the things that we want to do is we want to go through and we want to add our checking account. And if we look at our checking account, we would start with our class definition, checking account. Again, this is going to be each word capitalized. And when we try to inherit from a superclass, we have to specify which class we're extending. And in this case, we are extending our bank account. And then we can use our open and close braces. Now, this definition here, this automatically makes everything that we have created up here immediately available. So I could call the deposit function from within my checking account class. I can call the withdraw function. I can call this toString. I can go ahead and execute this constructor as well. I have access to these particular properties, all because I have this definition indicating what I am extending. And we've kind of seen some of these extensions where we're doing this in our Swift views. It's a little bit different, but it's kind of along the same lines with our protocols that we're extending. And we can go ahead here and in this case, maybe I have some additional variables over and above my account number, name, and balance that I want to add for my checking account, because maybe I care about the number of transactions that I do on my checking account, and if for some reason I exceed that number, And then I am going to have to pay some type of a fee and get charged that. So I can go through here and I can define a variable, because this is going to be my transaction count that's always going to potentially be incrementing. And this is going to be transaction count. And this is going to be type int. I'm not going to initialize it here. When I come down here, I'm going to declare two constants. The first one is going to be around how many free transactions I have available before I start getting charged. And this is going to be free transaction count. And I'm going to set this equal to an integer value, and this is going to be 3. Then I have also another constant that I want to set up here, and this is going to be for my transaction fee that gets charged when I exceed the count. So this is going to be transaction fee. This is going to be doubled because it's a money, and I'm putting in $5. Now on our initializer, we want to replace the super initializer. So when it calls the 2-argument initializer, we want it to use ours instead of the one that's in the super class. In order to do that, we have to use the keyword override and specify our init, passing in our account number, which is still going to be string, so these have to match pretty much what we have in the super class if we're just trying to override the existing one. Account name, this is going to be string as well. Here we're going to start with our field that hasn't a value to start out with, so we're going to initialize it here within the initializer, and this is going to be transaction count. We're going to set that equal to 0. Go ahead and call the parent initializer, and then go ahead and pass in the account number, and this is going to be the field that we have passed in, which is the same name, account number, followed by our account name, and passing through the value that was passed in, which is the account name. And that's pretty much how we would replace the parent one. We'll call ours, do what we need to do, and then we can call the super class to have it do its stuff that it needs to set in its class. Now, the other thing that we need to do is we need to increment our transaction count anytime that a withdraw or a deposit is made. So we need to override those functions as well so that we can add in our transaction counts. So let's go ahead and do that. We'll start with the deposit. So this is override func deposit, same argument amount. This is of type double. We're going to have the same output, which is bool. And within here, we're just going to say let is valid deposit because it's going to return a Boolean value. So we're going to declare it as type bool, and this is going to be assigned whatever value that we get back from that initializer call. Amount. We're going to go ahead and update our transaction count, adding 1, and return our is valid deposit. Going to do the exact same thing for our withdraw method. Override that. Has the same input, which is amount of type double. It's going to return a bool. We're going to set the let is valid withdrawal of type bool equal to super.withdraw and pass in the amount, and then we're going to go ahead and update our transaction count and return the is valid withdrawal. Now we've been updating our transaction count. We need to apply our fees at some point and deduct that from the account. So we're going to create a new method. This is going to be func deduct fees. It's not going to have any arguments or any return, and if we don't have any return, we don't need to specify a return type. This is if the transaction count is greater than our free transaction count. Then we want to go ahead and let our fees, which defined as a double is going to equal the transaction fee times, and this is going to be the transaction count minus the free transaction account, but that value is going to be an integer value, and we're multiplying an integer by a double, and we need to then go ahead and convert that integer value to a double. So let's go ahead and cast that before we even do that subtraction. So this is going to be transaction count minus free transaction count. And once we have our fee value, then we can go ahead and withdraw that from our account. So if super.withdraw amount, and this is going to be our fee value that we just calculated, then we can go ahead and reset that. So if we get a true back from that withdrawal, meaning it was successful, then we're going to update our transaction count and set it back to 0. The only thing that we have left to code here in our class is our toString. We potentially would want to see what our transaction count is. We don't have that in the superclass's toString. And since we're not necessarily replacing the same method with the same argument list, we need to go ahead, because we're going to add an argument, we need to go ahead and code that out. And we're just going to do that with a toString. Returning our string double, and int this time, and just returning the super dot account number, super dot account name, super dot balance, and then of course our transaction count. Now that we have all of this coded, we can go through and add some test code here, and just to facilitate a little bit of time savings, I'm just going to go ahead and paste some in. We'll take a look at what it's doing so we have some visual understanding of what we're executing before we try to run it. This is just to test our checking account class, and this is something we should always do. If we get one piece done, we should test it, make sure it works, then move on to the next. I'm going to copy it and paste it in. We're going to put in a visual delineation here, and we're going to create an instance of our checking account class, and that's going to have a value of C12345 with an account name of Karen. We're going to go ahead and deposit $800, withdraw 5, withdraw 100, withdraw 100 again, so we should have 4 transactions. Then we'll execute our deduct fees method, and we should see that our account gets charged, and then we can go ahead and print out our information from our toString call, because we're calling the toString method. In this case, we're actually assigning it to a constant, and then we can use our dot notation to get each of the fields out and print that out to the screen. Let's go ahead and save this, and let's come back here and run it. And we can see that we have $95 after we have done that withdraw after that initial deposit, and then applied the fees. And we have a transaction account that has been reset to 0 so that we can start doing that kind of transactions all over again. So that is our checking account. We have one more class to go through before we're done with this walkthrough, because we want to see potentially some more differences. And that is for our savings account. It is not as large of the number of changes that we have. that we put into our checking account. So if we come here and we start, we're going to define our class. This is going to be savings account. We're going to inherit from our bank account. In this case, we only have one additional field that we need to take care of, and this is going to be our interest rate. This is going to be of type double. We are going to create a new initializer, init, and this is going to be account number of type string, account name of type string, and then in this case we're passing in our interest rate, and this is going to be double. Put in my curly braces, and then in here I'm just going to set my interest rate equal to my input interest rate. So I have my property set from within my class instance to what was passed in this interest rate here, and then I can go ahead and I can call my super.init, passing through my account number and my account name. And that's pretty much my initializer. Then I'm going to have an add interest method. My withdraw, my deposit are just perfectly fine for this instance of my savings account. I just want to add some interest, so I'm going to do a func. In this case, add interest. It's not going to accept any arguments. It's not going to return anything. And I can come in here and calculate my interest. This is going to be of type double. And I'm going to get my balance from the superclass, multiply it by the interest rate, and divide by 100. Then in this case, I want to go ahead and I want to execute that super.deposit, and I don't really have a need to keep the Boolean value here. I'm just going to go ahead and use a shortcut here, and this is just put the result there, and I'm not going to use it. Okay, so I'm going to do a super.deposit and pass in my interest. The only other thing we have is our toString, because it's slightly different. I'm going to copy this, at least to try to save a little bit of typing. So I'm going to copy it, paste it down here. We'll have to fix it up a little bit. And we're going to have a double that we're returning instead of an int. And this is going to be our interest rate that we're returning. And then again, I'm going to go ahead and copy in some of the testing data where we're testing out the savings account class. I'm going to place it over here, and let's go ahead and copy this down here so we have some visual separation between the classes as well. So we're creating an instance of our savings account class, and that's going to be stored in our savings account variable. And it's going to be S12345 with mark, and it has an 8% interest rate. We're going to go ahead and deposit 800, withdraw 500, withdraw 100, withdraw 100, and then we're going to add our interest. And then we're going to call our toString method, saving our tuple as the savings account data, and then using each one of those dot parameters to output to the screen. So let's go ahead and test that. We should see about 108, I believe, being returned if we've done everything correctly. And let's go ahead and run this. And yes, we did calculate $8 because 100 times 8 divided by 100 is going to essentially be 108 that we're going to then have for our balance going forward. So pretty much this is our inheritance